Pine today. Leslie's going to start out by giving you sort of an overview of this project, and then I'll get up and talk at you for a little bit about some of the sort of science ongoing within the project, and then Leslie will get back up and tell you really about her work doing extension and outreach, which is an integral part of this project as well. Okay, so
Okay, so our title is Southern Pines, Carbon and Climate Change, and we're going to tell you how it all comes together in this project called PINEMAP, which is an acronym which I'll define later because it's so long, but you can get the idea. And we're going to just talk about forestry in the South, how Southern Pine relates to carbon, an overview of the project, the work that's being done on PINEMAP at UGA, and then ultimately the extension work that I'm more familiar with. So to start with, I assume this audience is non-foresters. And so when you think about, before you can think about this project, you have to think about how important forests are to the southeastern United States. So how much of the south of this area is actually covered by forests? So who thinks 20%? Hands raised. 20%? 40%? 60%? 80%? Okay, you guys are pretty good. 60%. So that's quite a bit of surface land area. And then when you look at that and you parse it out, a certain amount is owned by private landowners. And private landowners would be people who own from like 10 acres to 10,000 acres. So you're looking at someone with 10 back acres to Ted Turner with, I don't know how many acres. He's the largest landowner, but they're technically private landowners. So same numbers, but who thinks 20%, 40%, 60%, 80%? Okay, everything's all over the place. Well, again, it's about 60%. So tricky numbers. So that's just something to think about as you think about how this project comes together and how we are going to communicate this project. So in all, there's about 214 million acres across the southeast that are forested. This includes all forests, and I looked it up, and that would be, it's a little bit bigger than the size of Texas when you think about all the forests. A little less than 15% are owned by government. That includes all government, from National Park Service and federal government to county to state and everything. A little less than 30% are owned by industrial and financial companies. And industrial companies would be things like Rainier and other companies that produce paper or just timber companies. So we're talking about industry. And financial companies are actually investment firms that collectively own land as an investment and actually get great rates of return. And then 60% are what we call non-industrial private forest owners, because industry is technically private forest owners, but we're not talking about the industrial people. So in the southeast, if you're driving down the road anywhere, what species do you generally see? Like just general species? General? Pine, yeah. So, and specifically you see Loblolly Pine. It's fast growing and it makes excellent timber. It's native to the area, so that's why it's the prominent choice for almost majority of the plantations. And in all, southern pine plantations are economically and ecologically important for the area. And if you look at the global wood supply, from the amount that comes from the southeast, it's actually about 15% of the entire world's wood comes from just the southeastern United States. And considering we're probably about a quarter of the country's mass or land area, and we cover, about 15% of that, of the whole world, is a pretty big deal. And then when you look at the amount of carbon we store in southeastern forests for just the United States, we actually cover a little bit more than 30% as well. So in terms of carbon, in terms of timber, and actually in terms of just ecological importance like open space and all the other attributes that a pine plantation also has, the southeast pine plantations are very important. And annually we sequester about 76 teragrams, which is 76 million metric tons of carbon, which comes out to about a little less than 15% of regional greenhouse gas emissions. So we've got a lot going on in carbon. So being this group knows all about climate change, we know that it's going to increase climate variability across the southeastern United States. And our project is looking at how can we mitigate effects from climate change. So it's occurring, we feel effects already, I mean, I think most of you have heard that 2012 was the hottest year on record and one of the driest, so things are kind of pumping along. So our answer to mitigating some aspects of climate change is the Pine Integrated Network Education, Mitigation, and Adaptation Project, which I did not come up with the acronym, but it's pretty handy. And the project came together they applied for a grant from the U.S. Department of Agriculture, National Institute of Food and Agriculture, and they put out a request for proposals for what they called coordinated agricultural projects. And I believe that how it came together was that they also looked at pine being an important agricultural product as well. Excuse me. So we were able to obtain that $20 million grant. And I think there's three cap projects across the country. So the other one is corn, that focuses on corn. The other one focuses on wheat. So it's kind of an unprecedented grant level for something like this. So the project is massive. There's about 80 people involved, 52 scientists, 11 universities, and then 8 forest research cooperatives. Excuse me. The forest research cooperatives are actually a public-private partnership, and they've been around for about 30 years, and basically university researchers have been partnered with industrial, like timber industry, and they pay into a system to help fund research. So they've had about 30 years of data from those forest research cooperatives. We're also partnered with the U.S. Forest Service, and then my outfit, which is Southern Regional Extension Forestry. Excuse me, it's getting over cold. So our overall goals are to create the tools that help southern landowners to adapt, and what we want them to adapt is their forest management techniques. So what can they do to change how they manage their forests so that under changing climate scenarios, they'll still survive and thrive. We want them to more efficiently utilize nitrogen and other fertilizer things. And then ultimately we want to mitigate atmospheric CO2 in pines. So we want to use that pine forest productivity to keep the carbon that we're already storing, keep storing again. The PINEMAP approach is unique because we have 6 disciplinary aims, and they come together to contribute to broader integrated project goals. So up in the left corner is all the research groups, and we have the aim 1, which is monitoring or silviculture and ecophysiology. Aim 2 is modeling, aim 3 is genetics, and aim 4 is economics. So that's the research arm of the group. Aim 5 is education, and education includes kindergarten to graduate school level and non-formal education as well. Excuse me. And then we're the extension. I'm part of the extension group, and because I made this slide, you can see that I'm at the center of it, where our group is. And then we're working with the stakeholder groups, which includes natural resource professionals, industrial cooperative members, county and state extension agents and specialists, general pine forest landowners, and non-traditional groups such as minority landowners or people that might be willing to purchase land. And so the idea with the extension group is that we're getting the information directly and we're involved in the project, so we know what's going on right away, so we can start communicating to our stakeholder groups, and then also provide feedback to researchers to see if there's questions that haven't been answered. So the uniqueness is that generally extension is kind of after the fact and gets the information filtered down to them after it's been out for a while from researchers, but we're in from the ground level, so we're able to kind of move along quicker. So the first AIM group is silviculture and ecophysiology, which Dan's a part of, and silviculture is just generally forest cultivation, and then ecophysiology is just an organism's physiology, so how it grows, what it uses, and how it relates to the environment. And their general goals are to establish a region-wide monitoring network, and monitoring just means that they're going to get baseline data and say, this is what's going on right now, so that they can tell what changes in the future. And some of that data they have and some of that they're building on. And the basic things they're looking at are water, carbon, how many nutrients are stored, how those change, and then what their responses are to climate and management. And they're also using this forest cooperative data, which accesses like 30 years of historical data. So they have a lot of resources at their disposal. And Dan will talk more about that The second group is modeling, and modeling basically just takes information and turns it into a fashion so that you can make predictions from it or put it into some kind of usable form. And I have a more formal definition, which I'll let you read. But the modeling group within PINEMAP is looking at multi-scaled modeling programs. So they're going to look at all aspects of data that we're getting on the monitoring network and then put it into these different models to make more predictions about how things can be used or see what can be used. So I'll explain more of that in the future. And then they're also going to be able to assess alternative forest management systems. So across the monitoring network, things are being grown in all sorts of different fashions. There's different varieties of trees, and a whole bunch of information is being generated. So they're going to be able to compare those things with their models. The third aim is genetics, and while Loblolly Pines is a dominant species that is being, it's the species that we're dealing with in our project, and the dominant plantation species, the actual varieties vary considerably in growth and survival. So before they use particular varieties, when they introduced particular varieties for pine plantations, they actually saw their growth growth improve quite a bit. So using particular varieties is really critical to having a successful pine plantation and getting what you want out of it. And so they're going to look at those varieties and then look at actual genes that might be important for adaptation to climate variables. So they'll look at what varieties withstand drought, withstand windstorms or damage or things like that. So they're going to look at all those aspects of the different varieties. And then ultimately they're going to look at how a particular variety or seed might fit to a particular area. So this project looks at the southeast, but we know that the southeast encompasses a pretty wide ecological range. So we have Florida with sandy soils, we have coastal areas, we have the Piedmont where we live right now, and we have Texas and Oklahoma where the Loblolly range starts to disappear. So we want to fit the variety to the area. The fourth aim is economics and policy, and the important thing to remember when you're talking about pine production is that the markets are also going to drive pine production. So if we don't have any markets for the products, then people are not going to replant pines. They're going to sell it for real estate development or something like that. So when you look at this project as a whole, you also have to incorporate how the economics and any policy changes at whatever level are going to influence the markets and ultimately influence how people manage their land. And this group is going to look at all aspects of policy and economic analysis, and they're also going to include the non-market forest benefits, so the ecosystem services that these forests provide. So encompass everything together. Education is the fifth aim, and I said that it'll include kindergarten to graduate students, as well as environmental education programs. A lot of what they'll be doing is developing curriculum and providing information so that these different topics can be taught. And then even within the project, we are trying to integrate our graduate students so that someone who is working specifically in silviculture on the project and someone who's working on economics or someone who's working in extension, especially those different graduate students, that they interact and they learn some of the skill set from their counterparts or learn more about what the other person is doing, so that it's not going to be, in the future, things are not going to be as strictly disciplinary. So we want to look at the interdisciplinary aspect of putting this project together, and since graduate students are the future, we want to get them combined. My group is extension, and extension is just knowledge and technology transfer, and all the universities that we're working with are land-grant universities, and as part of the land-grant university mission, the extension system was built, and extension includes forest extension, agriculture extension, home economics, so there's many different aspects of extension, and that system is already like an existing and functioning one. So there's already a forestry extension system where extension specialists at county levels, at state levels like Georgia Forestry Commission or UGA Forestry Extension exist at different levels, and they're already working with folks. At our level, we're trying to create information and products for those folks to then communicate the message to our stakeholders. And we're working with forestry research and then also with climate scientists to get that word out. And now we'll switch over to Dan. You're talking about PINEMAP at UGA.
Okay, thanks. So that was a good overview of all of what's going on in the project. At UGA, we are focused on just a few of those aims more than some of the other aims. The first slide up there just informs you, that the forestry school, which is of course now the Warnell School of Forestry and Natural Resources, is the oldest forestry school in the South, was established in 1906. And you know what? We didn't really have pine plantations in 1906. So our school was really formed with a much broader view of forests. And I would like you to be sure to walk away with that vision. 50% plus of our school is focused on wildlife issues. Many of our faculty and students are really wildlife students. We have a program in natural resource recreation and tourism. We have a small group that focuses on water and soil resources. And then really about 30% of our program students are specifically in the discipline of forestry. Okay, so we are broader than simply pine trees. Daniel B. Warnell was a native Georgian, a businessman. He was a state rep from 1931 to 39, a state rep and then a senator. And really, of course, his family gave us a little bit of money, and we became the Warnell School. We used to be the Peabody School when we were first formed, just like the Peabody Awards. And I don't know how that works, and they just take your school away from you. Okay. The other thing I would like to emphasize is that these cooperatives that Leslie introduced are really a very integral part of this project. Okay, and they're really a very interesting model because they are a public-private partnership. And if you think about this, Loblolly pine trees really started populating the landscape after the Depression in the 30s when we abandoned a lot of agricultural land. And nobody went out there and planted loblolly pine. They just happened to be in the neighboring forest. They're pioneer species. They have light seeds that have wings on them. And they naturally seeded in those agricultural fields. And in the 50s and 60s and 70s, when we started harvesting those trees and the pulp and paper industry started to grow, there were naturally questions about, well, how do we actually now very purposefully repopulate these fields with pine trees? Okay, and at that time, as the forest industry was growing, some of the industry was developing their own research projects. But they had the good sense to look at the land-grant institutions and partner with those institutions. This whole list of acronyms you see here, the Plantation Management Research Cooperative is the cooperative at Georgia, but then there's the Forest Biology Research Cooperative and the Forest Genetics Research Program at Florida, the Forest Nutrition Cooperative, the Tree Improvement Cooperative. It sort of just goes on and on. The Plantation Management Research Cooperative at Georgia has about 23 members right now. Each of those members pays an annual fee to the co-op. And then the co-op has a few $100,000 budget a year to undertake large-scale research. Of course, these industrial cooperators own land throughout the region, so a lot of these studies are region-wide studies. And so if you think about trees, they're a very different crop than corn. We cannot study trees on an annual basis. It takes 20, 30 years to grow a rotation. So the genetics that we planted in 1985 are what we're harvesting right now in 2012. Now, granted, what we planted last year in 2011 was the latest and greatest genetics, but we won't see the benefits of that. And what the climate might be 25 years from now could be quite different. So one of the great advantages of this study is we have thousands, literally, of plots on the ground that have been there for 20 or 30 years that give us some sense of what the expectations are regionally for forest productivity in this region. Okay? And of course, private landowners own a lot of land. And then, in fact, they actually really produce most of the seedlings. A lot of this used to be done by the state, but really a lot of it has been taken over by private companies. Okay? And they're the ones really most interested in that data. So here's a little graphic just sort of touting the benefit these contributions of improved management to pine productivity. 1940 is kind of our baseline, the average productivity tons per acre that might have grown on a plot of land. And then if you really look at the natural stand, the first things we thought about was how to plant trees, how to prepare a site. Of course, we used to do really silly things like plow it all up and make it look like a farm field again, because we thought that worked the first time. Why not do that all over again? But then we started thinking about things like fertilization and weed control or controlling competition. And then most recently, tree improvements, or kind of biotech is really the genetic part. Of course, tree improvement originally used to be going out to the field saying, oh, wow, that's a really nice tree, collecting some cones from that tree, taking its seeds and planting those seeds. Of course, then we started moving into things like controlling pollination, and now clones are actually being planted on the landscape. Okay? And one thing you might notice here, so the productivity has quadrupled over these last 70 years. When you think about that, that's very nice if you're an industrial producer, but that also has some important environmental benefits. If we're interested in growing houses or producing trees, nowadays we can use 1 acre for what used to take 4 acres. So that means we have 3 acres of land to do something else, like protect water quality, or to put houses on, or to develop suburban sprawl. Okay, but in large measure, it's sort of that argument, should we really be very efficient on each individual acre so that we can do other things with those other acres? Okay, and in large measure, this program has allowed us to take that approach. Okay, so here's just an example. Here's a pine plantation on your left in the coastal plain of Georgia, marine sediments, no fertilization, 20-year-old pine trees. Could make some really nice toothpicks out of that. On your right is a plantation that's received 50 pounds per acre of phosphorus, about 50 kilograms per hectare, just one time at planting over 20 years, and there's virtually a 10-fold increase in growth. Of course, growth equates to carbon sequestration. So if you look at those two systems, there's a lot more carbon being stored in that system on the right, probably both above and below ground, than that system on the left. Right, of course, over the years, forestry and forest product companies have been pushed by society, by people saying that they actually care about things like endangered species, okay, that they care about things. These are, of course, stream-side management zones where we're not allowed to cut trees. That's not exactly true. You're allowed to cut some, but not as many. Because we care about water quality. Of course, we care about diversity. Both genetic diversity is an issue these days, as well as biodiversity. Okay? And I think that landowners and industrial owners have very much responded to that because society has demanded that of them. It hasn't really been a choice. Okay, so let's talk a little bit more specifically about PINEMAP. Leslie kind of identified these particular goals in terms of mitigating carbon, utilizing nitrogen effectively. Of course, you realize when you produce nitrogen fertilizer, you use a lot of energy, so you have to kind of put a balance together and say, well, if I'm going to grow more trees by fertilizing them, how much energy do I really use in the fertilizer? Is that outweighed by the added growth? In the case of trees, it typically does work out pretty well. Nitrogen also has the downside that it puts a different greenhouse gas in the atmosphere, right? N2O, nitrous oxide, is a byproduct of nitrogen fertilization, literally putting it on the ground. So we are out there trying to measure, well, how much of this other greenhouse gas are we putting in the atmosphere if we're going to manage this way? Water use, of course, a critical issue. If you're increasing growth, is that costing you in terms of in-stream flows? And then we would like to make forests more resilient. And of course, by that we simply mean when we have a strong drought, we'd like our forests to actually survive. When we have a strong storm, we'd like those forests to actually function, provide things like water filtration after the storm passes through. Okay, our project's not doing a whole lot with pests. The funders didn't really request that of us, but of course that's a big issue in terms of resilience as well. You'd like your system to be somewhat resilient to outbreaks of different pests and diseases. Okay? So my group that I'm working with, I'm going to talk to you about AIM 1 and 2. Leslie will talk to you a little bit more about AIM 5 and 6. With AIM 1 and 2, there are 6 different senior investigators, myself, Dr. Bob Teskey, Michael Kane, Dehai Cho, Bill Hubbard, and Marianne McGuire are all PhD level scientists working on the project. There's a couple of full-time project coordinators, Leslie being one of them, whose salary is largely coming out of the grant, as well as some other grants. And Madison Akers is full-time on this project as well. There's 6 different graduate students, some of them sitting with us here today, that are on the project. You'll see a little bit of their work. We have any undergraduate students in the room today? No. 1, 2. Good. All right. So we actually have an internship program that, again, was part of this project. If you're interested, go to the PINEMAP website. There's actually about $7,000 available per student to integrate undergraduates on the project. They're designed to go work with a graduate student. They could do that here in Georgia or visit some of our partner institutions. And then eventually we would force them to take what they learned and be an extension agent and go into secondary schools, and actually we'd give them a little bit more money to keep them on board so that they could go to middle schools and actually help kind of pass this information down the line. Okay, so what are we doing? We have 3 levels of study in this project for kind of the science arm in AIM 1 and AIM 2. Tier 1 is sort of the broadest level, Tier 2 a little bit more refined, and Tier 3 is sort of the smallest scale project. Okay, let's just, all of these kind of studies incorporate a systems model approach. Of course, we want to understand things about the stock of carbon in the atmosphere. So this is our box. And photosynthesis, of course, some of that carbon in the atmosphere moves into trees or biomass. So we create box and arrow diagrams or system models to think about this flow of elements through the system. And we could do this for carbon and water and nitrogen. And the useful part here is you can try and assess, well, what's really critical? What flow, what movement from one box to the other seems to be a critical driver or attribute in that system? And then that really gives you some information about where I might want to manage that system. Am I really trying to manage the above ground box or the below ground box? Is somehow this flow out of the bottom box really critical, or is it really this flow in the top of the box? Okay? And so that kind of systems model approach kind of is overriding for all our research. These legacy studies are really designed to make use of these 30, 40 years of research that are ongoing. So for the legacy studies, a lot of the data is already available to us. And much of that data is really in the form of growth data. So there's lots and lots of plots where we've measured tree growth over the last many decades. But of course, like all things, a lot of these cooperatives, of course, they have members and those members pay them. So they don't always actually play so nice together, right? Because they're competing for members. And so over the years, there's certainly been some sharing of data. There's been a lot of data published. But in this case, all these different partners agreed, and the industrial cooperators, who are fully aware of this project, agreed to let us pool this data in ways that we've not done before to really try and develop some region-wide models with all the available legacy data. Okay? And so that'll really be done in a few different modeling approaches. On the left is really just a lot of curve-fitting type approaches, what we call growth and yield modeling, where we develop different kinds of equations with lots of parameters based on last year's diameter or last year's basal area or basal area 5 years ago. Okay, the basal area being the size of the trees relative to the size of the land. Or we can create these sort of box and arrow models, these process-based models, where we might be interested in understanding something about water use. Of course, we're certainly interested in the net primary productivity of that system. Okay? And so maybe it's photosynthesis that's critical, or water use that's critical in terms of controlling that growth. Here's a little bit of data from Maggie Wang, who's a doctoral student working on the project. And of course, our ability to actually fit the growth patterns in different regions, or our inability, might be really useful in informing us about things we do or don't understand. Okay, so here's an example simply from Georgia where we did a nice job, basically the same model applied to Alabama, and clearly it's not as good. And so now you might want to go to Alabama and say, why don't we win national championships? You might want to go to Alabama and actually study those for us and see why we don't fit that model quite as well. Okay? And of course, then there's the desire to scale up. What we were just talking about is really plot level data. Of course, we're not really interested in the plot level. How we scale up is really important. Do we just model lots of little tiny plots and sum them all together? Or do we, in fact, make use of some kind of remotely sensed image or some soil maps or some precipitation maps and really try and model at a larger scale? Okay, a lot of the larger scale modeling is not really going on here at Georgia. Okay, so that's not what me and my colleagues really are very good at. I know Nate Niblink actually gave this talk a little while ago. Nate is really good at that stuff, but he tends to study critters rather than systems. So, okay, so let's talk about Tier 2 for just a second. This is a little bit scaled down, and the idea here is those, like that Alabama example, are there places we can go where there's active research on the ground? So some of these legacy studies are done. You know, those trees have been harvested. Maybe the particular cooperator doesn't really own that land anymore. But there are clearly many studies that are still ongoing where we can go out there and we can measure current rates of water use, or we can measure current rates of carbon efflux or carbon sequestration. And so we've selected a range of these where we will go out and measure certain processes, the pools, the simple amount, or the fluxes, the flows on these different stands. Okay, and really, of course, the goal here is really to help us validate those models that we looked at in the last step and improve those models. Okay, and so this is the case. Miles is not actually, well, he's kind of affiliated with this project, but this is the case where students will be going out throughout the region. The different entities, so like Oklahoma State and Texas A&M, and their students are sort of in the western region. Of course, the University of Florida is the lead university on the project, and they're sort of their own region. Georgia and Auburn are sort of the central Piedmont region here. And then North Carolina State and Virginia Tech are sort of the north and eastern part. Okay? And so our different students will go out to these different regions. And like Leslie was saying, we're trying to create opportunities where maybe we'll have our annual meeting. It's very nice to meet in Atlanta because everybody can fly there. But we are committed to try and maybe going to Oklahoma or going up to Virginia and trying to get students to these different regions a little bit. Okay, and there will be hundreds of plots that we'll try and sample, although our goals might shrink as reality settles in. Okay, so let's talk about Tier 3. This is the last and really finest level of study. This is the through-fall exclusion by fertilization study. Okay, and so there are three locations represented here. Of course, Oklahoma is actually doing the same exact study. Okay, and really in this case, you can see what we've chosen to do is really exclude water from these plantations. Okay, and of course you recognize that CO2 is of course increasing in the atmosphere. A little question, really strong empirical data. We've done a lot of studies. 20 years ago, we started looking at the response of plants and other critters to CO2. Of course, after that, there's concern and a good physical basis why CO2 might increase temperatures. So there's been a lot of research on the effects of temperature on plants, a little bit trickier to do on systems, although there have been some studies, particularly in the soils world. And then if you saw Pam Knox's talk, of course, she talked about a little bit the perception that rainfall might get more seasonal in the southeast, or maybe we'll even get a little bit drier. And that's really sort of where we're heading, saying, well, that's sort of the biggest unknown right now, and what are we going to do in that case? Okay, so in this case, as water falls through the canopy, rain comes through, it falls through, so it's called through fall, and we really exclude the through fall, and we take it off in these pipes to some other location on that plot. Okay. Of course, all of these vary in their soil types, whether they're clay-rich or sandy, and then we have multiple measurements that we're taking in each of these stands. They are large scale, so here's our site in Washington, Georgia. It's well replicated. There's 4 blocks, there's 4 treatments, there's a control, a fertilizer, a rainfall, a really through-fall exclusion, and then the interaction of the two. And then they are blocked. They're actually kind of random blocks. They look random, but they're basically based on existing tree heights rather than location. And then all of these have to be instrumented, and we're trying to measure all these 16 plots, and this is going on in 4 different locations. Okay. Of course, there's a little bit of data here. Jill Chi is a student working with me. We're excluding rainfall. The soils are getting drier. Okay, that's good. Great success. All right, we've proved that hypothesis. Less water, drier soils. Okay, so here's the treatment with a little bit drier. And it does matter where you are. If you're right under a gutter, it's particularly dry. If you're within the tree rows, it's a little bit wetter. Okay. Although that drying, trees have already responded to that drying. What you're seeing on your left here is a way that we measure water flow through trees. So this is Dr. Teskey, who does a lot of this work with Dr. McGuire, Mary Ann, where we put these probes in the trees. We pump a little heat into one probe, and then literally the water flowing up the tree carries that heat to the other probe. And you can actually measure how much heat makes it to that probe and make an estimate of water flow. You can actually heat the probes a little differently, but okay, and here's a little work from one of our colleagues at Auburn University, Joe Clark, and the short answer is that the bars that are black, where there's rainfall exclusion, there's literally less water flowing through the leaf, which we call stomatal conductance, than in the areas where we haven't excluded the rainfall. Okay, and he's been doing that for many months. Okay, and finally, Jian Yang and Cody Lukey are out there measuring CO2 efflux. So there's a little chamber. Obviously, CO2 will move into that chamber. You can measure the rate of increase of CO2 in that chamber to estimate the flux. And you can see that, in fact, CO2 efflux, this is actually the fertilized treatment, but the results are quite similar for the rainfall exclusion, is actually less than under the control conditions. Okay, so there's been multiple responses of the forest to this treatment that really was only imposed in really April 2012, so it's not even been a full year. Of course, now the trees are dormant, differences are not quite as great. Okay, the only thing I'll try and leave you with is that the systems are complex, and integrated responses can kind of balance out. So if trees, in fact, are using less water and growing less, you might say that there's less carbon in the system, but on the other hand, we're seeing less carbon come out of the ground on the bottom. And so if there's less carbon coming out of the ground, maybe you're storing more of the carbon that you put in here, even though maybe you're accumulating a little bit less above ground in those trees. Okay, and so that will be our job to really assess, has there been an overall decline in the system, and maybe what would you do about that over the couple of years of the project. We're in year 2 of 5 years of the project, and so we hope that the information will be useful in sort of addressing how landowners might adapt to these systems. Should they fertilize differently? Should they maybe plant at different densities? If water's an issue, maybe I should only put 300 trees out there rather than 600 trees out there. So there are multiple things that we might think about trying to do. We might just plant a different species altogether. Okay, and so those are sort of our goals and where we hope to get to somewhere in the next 3 or 4 years. Okay. So Leslie's going to come back and tell you a little bit about her efforts to try and eventually get that information out there.
So Dan's kind of explained some of the questions that we're trying to answer and how we're going about it, and as you can see also that questions lead to other questions, but by pulling all this enormous data, we should be able to come up with some decent answers. So tasked with, my group is tasked with actually getting that information out to people. And so our goals are just, at the most basic level, are keep the land forested. So if it's already in pine plantations, we want to keep it in pine plantations. We want to plant more trees to absorb more carbon. And so we want people who might have open fields to consider turning that into pine plantations. And then ultimately we want to create more resilient pine plantations so that the ones that are planted are going to survive if there's increasing catastrophic weather such as hurricanes or tornadoes, if there's drought, if there's floods. So we want to make sure that these pine plantations are going to survive. Our group includes about 12 members. There's from 6 universities, including all extension staff. I think we have 4 or 5 like PhD level people in our group. It also includes myself and my boss from Southern Regional Extension Forestry, and we have graduate students as well, and a couple other staff members. We're working with 3 general audiences, so I went over briefly. We have the private landowners, so we're talking 10 to 10,000 acres. We have industry professionals, and then the group that we're focusing on quite a bit is professional foresters. So there's people who work professionally as consulting foresters, so they might work for someone who's a large landowner and manage their land. And then extension foresters, people who work for the government, who might work for the university extension system or Georgia Forestry Commission or something like that. So that's kind of our general audience. And there's many challenges for reaching our audience. The first one is that forest landowners may not be concerned about climate change or motivated to respond. This graph on the lower left is taken from what was called the 6 Americas study, which I think many people are probably familiar with, but basically some researchers in Yale polled the general public to find out what their belief was on climate change, and then put them into 6 groups. So alarmed, the concerned, the cautious, disengaged, doubtful, and dismissive. So on the left side, it's the highest belief in global warming, and the most concerned, the most motivated to act. And on the right side, it's the lowest belief in global warming, and the least concerned and least motivated to act. So you have about 50% of the population are alarmed and concerned, and then the other 30% of the population are disengaged to totally dismissive and don't believe it, and then 20% kind of in the middle think it might be a problem. And so these are our clients. They don't. So one of the challenges is, well, how do you reach out to an audience and tell them that they should prepare for a problem that they don't necessarily think exists? And so another one of our audiences is extension professionals, and extension professionals in forestry and natural resources have at least a bachelor's degree and also could have a master's degree. So the thought would be that these extension professionals would be more educated and be more willing to act and be more knowledgeable about climate change. However, one member of our extension group conducted a survey of extension professionals. She gave the exact same 6 America survey. And when they looked at the survey results, they found that if you look, the red is Southeast Extension professionals, and then the blue is the general U.S. public. And they pretty much came out the same. So there wasn't a bias towards the educated extension professionals. They didn't believe in climate change more than the general public. So that's something to think about as we design educational programs to reach this audience. And extension professionals they're the people that we want to kind of spread the message. So we have to keep that in mind as we go along. And so when we have been working on designing our programs, we want to focus on what is most important to our clients. And what we've chosen to focus on is forest resiliency. So ultimately, climate variability and climate change are going to cause all these threats that currently exist to forest threats, to be exacerbated. But they already exist. So we already have drought, we already have hurricanes, we already have tornadoes, we already have floods. But it's just that those things are going to be either more variable or more intense. And so anything we can do to increase the resiliency of the forest would protect against current threats and then also future threats from climate change. So that's what we're kind of focusing on. But to get started in our general program, we're conducting a needs assessment survey. We're just about to launch a poll to 10,000 foresters across the Southeast find out their views on climate change, but more about what kinds of things they'd be interested in learning along the forest resilience continuum. And we want to use some of their feedback to create dynamic educational programs. Some things would be in-person workshops, webinar courses, and just anything else that we think will work. And ultimately we want to use what they care about to reach them with a message, because if we just, we want to educate them on climate change and what's going to happen, but that doesn't really matter to people unless they can do something about it. So we want to change the focus back to what they can do. And what we have also come up with is that we want to develop climate-smart forest management. So we want people to consider climate whenever they're using any forest management techniques. We want to put that all together. And we want to train forest resource professionals. And then we want them to actually perpetuate the effort. So we want to reach a critical mass so that people are spreading the information around. Then we also want to work on educating current and potential pine plantation owners, because we saw that 60% of the land is owned by by private landowners, and we want to reach that group as well. So we just launched this past fall, we launched a webinar class series called Natural Resources Opportunities for Landowners, which just went over the basics of owning land. It's predicted that there'll soon be a generation shift where there's a lot of people in their 70s and 80s who own land, and that land's going to be left to younger generations, and those younger generations don't necessarily have any of the general knowledge of the land. They didn't grow up there, they grew up somewhere else, and so we want to reach that audience and make sure they know about what can be done with their land. And again, we want to keep the effort going. One of the main products of the extension group of PINEMAP itself is going to be a decision support system. And it's just a web-based tool that provides guidance based on PINEMAP research. And what a decision support system is I have a picture here of orbits, but that's a decision support system. So you say you want to pick a flight, or you want to pick a hotel, or a flight plus car, you put your information, where you want to go, the dates, and then it spews out this different information. So we're going to design a similar decision support system for PINEMAP, and it's going to be all guided on PINEMAP research. So the models that the group develops based on the monitoring information from the AIM-1 group will then be turned into a multi-model system so that you can input where you live and your particular region and find out what might be best for your area. So that's coming along, and at this point we're developing kind of two parallel systems, one for the more educated person and then one for someone who might be like kind of a more novice or less informed. And that should link our research, extension, education efforts. So, and then finally, what we see as PINEMAP success is just more land planted, replanted with improved forest management techniques, better water efficiency and nutrient use, improved forest resiliency, and ultimately more carbon sequestered as well. And that is it. You guys have and if you have any questions, we have a Facebook page if you want to keep up to date on the latest.
We have a web page. I was going to say one quick thing. Heather actually asked me today. We actually do have an online graduate course that's going to start January 15th. And generally it's been students involved in PINEMAP, but if for some reason you had a particular interest in doing this online course as a graduate student, and if you contacted one of us, you could probably get involved.
That's all right. I could pass through that information you sent me to our listserv.
Well, you pass everything but how we're going to grade stuff. That would be fine. So the syllabus you can certainly put out there.
Okay.
Yeah.
That's a secret.
Yeah. Go ahead.
Very interesting presentation. So, how big of a species is Loblolly Pine if you look at predictions of increased drought over the next 10, 20 years?
Yeah, so one of my colleagues, Bob Teskey, has done some really nice work, and it was really on smaller trees, seedlings, because it's easier to control, and it was largely a small greenhouse study. The trees are amazingly resilient to increases in temperature. So even like 5 degrees centigrade they didn't really seem to care. They grew pretty well if you gave them a lot of water, because then they could cool themselves. If you don't give them enough water, they pretty quickly slow down their growth. So is pine drought tolerant? I don't know. It's been around the southeast for a few thousand years and has made it through a lot of droughts. So I don't want to say it's not drought tolerant. Of course, what it does is it slows its growth, which is not really necessarily a problem unless your income is dependent on its growth. But it doesn't generally die. The drought would have to be really severe for it to die. And I think that's true for a fair number of tree species. They're pretty good at tolerating drought and slowing down. So, right. So pines are pretty good.
Yeah.
Time was when a lot of the pinelands were owned by corporations, insurance companies, things like that. Is that still true, or has that changed in terms of, you talked about landowners? I mean,
Yeah, that changed. I don't know when. I don't know the exact time period, but I think at some point it used to be so it was all owned by the timber company or by like big paper companies and different things like that, and then I believe it was in the 1990s when they divested the land.
Right, so probably over the last 10 to 15 years, really largely over the last decade, what's happened is it was very expensive. So we used to have vertically integrated paper companies. They own land, they own mills, they produce products and sold them. And they used to think that that was really useful for controlling prices. So during like really wet periods, it's hard to harvest, prices can go up. They felt like, well, if we have our own lands, we can harvest off those lands, control this important input to our system. They were very good at getting the government involved, research, extension, land grants. We got a lot of people planting pine trees, so lo and behold, there's a great abundance of pine trees out there. It worked out that their land holdings didn't really affect the price in the markets, and it was very expensive in terms of taxation to maintain those properties. So about 15 years ago, the actual company started divesting, and really what has happened, these insurance companies you speak of, like a John Hancock, which is really a financial company, they really stepped in, and we say there's timber investment management organizations or REIT, real estate investment trusts, and they have a much more favorable tax structure for maintaining land. And so a lot of land went from people like International Paper, who sold really millions of acres, into more of these like financial companies. And they're really like John Hancock, they have a lot of pension money, they dump that into land. That has kind of worked out really well for them when the stock market plummeted here and they were just sitting on a lot of land. For a time, when returns on the market were really great, land didn't look so wonderful. Of course, when the market crashed, land looked really wonderful. And so there's been a growing interest in sort of having this asset of land. And trees, like housing starts are down, but the trees keep growing. So you're not really necessarily making that much money right now, but your asset is growing. So again, it has sort of a lot of favorable things. So right now, a lot of the big landowners are definitely these kind of financial institutions and these REITs. Some of them, like Georgia Pacific, which still makes paper, they split in half and they created a real estate investment trust for their land holdings and a manufacturing company. So the answer is yes. There was a question in the back. Will you tell us who you are when you ask a question so we know a little bit?
I'm Gary Rose and I work in the marine science department.
Thank you.
And I was wondering, in the beginning you told that about 80 kilogram of carbon dioxide is absorbed by forests.
Mm-hmm.
And I was wondering when it is degraded or used in industry, then you probably produce again carbon dioxide. So do you know what the net effect is of forests on the climate?
Yeah, so the answer is if you look across the southeastern region over the last 40 years, forests have been accumulating. So whatever our harvest has been, the yield has been below the growth. So I appreciate your point. If I grow trees and I cut them down and then I make them into paper, a lot of that goes back into the atmosphere. Of course, if what I do is grow trees again right away, ideally it's a net zero. And really regionally, the region has been accumulating or sequestering that amount beyond what we're harvesting. So that's really the growth beyond the yield. So it's really stuff sitting out there in the woods that's just accumulating on the stump. Yes?
Yeah, thanks for a great presentation. I'm Chris Cornwell. I'm in the philosophy department and women's studies and environmental ethics certificate program.
So we love that, to know people from philosophy are here. Thank you.
Well, now you'll hear my question. No, I've got two questions. One is just informational. Are any of the cooperatives located on tribal land?
I don't think so.
Right, none that I know of.
No.
They're all based at land grants.
Yeah, okay. I was just curious. Super intrigued about AIM 5 and education, and I loved your kind of overview of some of the challenges and thinking about reaching stakeholders or different audiences. For the climate initiative, and also I'm a member of the Georgia Climate Change Coalition, which is a community-based organization. These questions about, so it's like stakeholders are just like the public, you know, and sort of like public education.
Mm-hmm.
Are you, so I kind of hear that you're kind of balancing this, educating folks about, how did you put it, climate smart forest management and forest resiliency, but you've also got to be educating them about climate change in order to kind of motivate them to take things seriously, or to kind of see the forest in the context of kind of the new normal.
Mm-hmm.
So are you developing, who's working on that part, and are folks developing or using curriculum to educate folks just about climate change and greenhouse gases and sort of like the basics? Or is that part of the aim? And who is involved, and how can we help?
Well, I will say, so Martha Monroe, who was one of the people who did the Six America study with extension professionals, she presented to some of the extension leaders at the University of Florida, so for their extension system. And so there hasn't been real general interest at the extension agent level because they have so many things on their plate. And of course we know that we've reduced the extension budget considerably, so they have a billion things to learn about. So they're not going to go out and learn primarily about climate change unless they're either directed to or it comes from their stakeholders that they want to know about it. Anyway, the extension leaders in Florida were really interested to find out about their employees' views on climate change, and now some of them are interested in making that more of an issue. Maybe that has to do with Florida being being a peninsula or something. So we're actually going to meet this month to talk about developing some curriculum for extension agents that's more just climate change general. So, and we've looked at there's a couple initiatives we're working with nationally that is also talking about more extension agent education, like at just a climate change level, and then spinning off into, well, here's your forestry effects, here's your agriculture effects. So yeah, I guess we are developing those curricula and working with other groups. And there's a lot out there, so we're trying to not reinvent the wheel, but then also build it to our client-specific interests.
Well, in
Wasn't
Georgia,
there just a
yeah.
Project Learning Tree module that was just created?
Mhm.
Do you know Project Learning Tree a little bit?
No.
So Project Learning Tree is sort of these educational modules, and they have some on water and what
It's
else?
a general environmental education, and it's a curriculum that's used at school level. It's been around for a long time. I don't actually know how long it's been around, but so people become certified Project Learning Tree educators, and so they're developing. They're in the final stages of developing curriculum for that.
In Georgia, there's so much extension work tied to energy.
Mm-hmm.
And it's usually kind of household efficiency and that sort of thing, but that seems to me like a potentially ripe area, because extension agents are already trained in educating about energy efficiency in the home and that sort of thing. So I've wondered if that might be a potential place to kind of connect with climate change education.
Yeah, I think that might be one avenue because, again, energy conservation comes down to like saving money. That's a good message. So you can bring it back to, okay, well, you're saving carbon too, kind of as a backdoor way to bring in. Oh, yeah, sorry.
They're putting a lot of pellet facilities in the pine forest, to send the carbon over to Europe because they've signed the Kyoto Protocol. Is that affecting at all your project? Or I hate that we're taking the carbon off our soils and sending it over there.
So there's a huge market right now for wood pellets. So in Europe, there's different country, or I don't know if it's EU regulations that say that a certain amount of energy has to come from bioenergy, and so they're buying it from us, and a lot of it is coming from Georgia and from the East Coast because we've got the barges and everything. That's just there's a lot of growth right now in that in general, so it's just another market for a product. It's a low value product because you're using like residuals or like lower value timber.
So the answer is it's a vastly growing market, but of total tree harvest, it's actually a pretty small percent still.
Okay.
I hate to give you bad data, but if we're harvesting, it's something only like 5% of harvests are actually going to pellets. Evan Johnson, any ideas there? Okay. So it's growing much quicker than the pulping industry, but it's really not that big a number. The upside of it is, like Leslie said, if you want landowners to continue to maintain lands in forests, then they need some place to sell their timber or their pulpwood. I would argue with you that the other alternative, if you prefer, is we can turn a few tens of millions of hectares into switchgrass if you'd like. If you were to ask me, I would say we're much better off to continue to grow pine trees, keep a forest cover, and not worry about growing switchgrass.
Which is another biofuel.
Which is another biofuel, thank you. And so it is affecting us. I think most people would say it's affecting us in a good way. It really works out that they are sort of competing with the same market. As you're probably aware, pulp and paper, it's a very old industry. It's not really growing. So landowners are very happy to have some new markets developing for their products.
And you just
Last
don't like
question.
it because it's getting exported? I'm just curious why you don't like it. 'Cause it's,
Yes, that's a big part of it, that's exported.
Right.
Okay,
Yeah.
I just
One-
wondered.
I have never actually seen, so we talk about life cycle analysis a little bit. So like you might ask the question, okay, we cut down these trees, we put them on a truck, we drive them to a mill, we beat them up, we put them through an extruder, we chop them up, bag them. Actually, we don't really bag them. We put them in these massive containers. We float them across the pond.
Yep.
We put them on another
It's
truck
hard to
or a
do.
train.
I
We
know.
bag them.
That's
You
part of
you
it
might
too. It
ask,
makes-
like, in the end,
makes no sense.
does that really emit less CO2
Right.
to the atmosphere?
Right.
I've not really seen anyone
Right,
who's
that's a
really
big part of it.
done that math. So,
Is in the economic modeling that was referred to in there as part of the overall picture, is anybody working with figuring in potential prices, sort of if there were a market, if they could sell, landowners could sell carbon credits to markets? Is anybody kind of working with that?
I'm not sure how much they're looking at that, just because there hasn't been much talk about it from the top. There hasn't been any like policy push from. I haven't heard anyone talk about carbon credits in a long time. I think a lot of that data exists, though. I think because for a while there's a lot of talk about carbon credits, and so I'm sure that there was some initiatives going and some kind of work was funded on that. But I'm just saying this off the cuff. I'm not sure.
yeah, there's definitely work out there. Bob Apt is sort of the lead economist in the group. I think he's at NC State. He works pretty closely with some folks at Duke that are not really part of this project. And they've got a couple of these analyses out there as what it would take to really entice landowners to sell land for carbon credits. In the state of Georgia, A couple of years ago, maybe 7 or 8 of them, our school, a number of us in the Warren School, were actually asked to help develop a protocol for registering carbon credits, and that was really done through the Georgia Forestry Commission. And we have a registry. We have like 3 registrants or something really pitiful. And so the state actually, they were kind of forward thinking and wanted to create some protocols. The state definitely did not want to be the one paying anybody. They just wanted to facilitate the development of a market and wanted to try and ensure that everybody was an honest broker. So that they asked us, well, if you were going to account for carbon on an acre of forest land, how would you have them do that? How could you help them ensure that they were really sequestering that carbon that somebody was paying for? We put those protocols together, and I don't know that anyone's ever paid for a ton of carbon in Georgia as yet. I'm a little uncertain, but I don't think so. Yes? You got to tell us who you are.
Sure. Ross Pringle, I'm from ecology. And you were saying in the beginning that the 60% of the southeast was forested. And I was wondering how that breaks down as in plantation that's planted, to be harvested, and actual just like natural forest sort of thing, and how those differ and how they support biodiversity of other plants and animals.
So 1 in 5 acres in the state of Georgia, about 20% is pine trees. I think that number is relatively close for the southeast region. And so that 1 in 5 acres or 20% is planted pine. Of course, we have a lot of acres that are mixed pine. They're not as intensively managed. They got a lot of hardwoods in them. I like to say I'm a what the flux person, so I'm interested in fluxes of energy more than I am a lizard squeezer. I don't really go chase critters. And so, again, what I would tell you is that, southern pines are native to the region. There is a subset of species that are dependent on those systems. They are monocultures and agricultural systems. They certainly lack diversity in some ways, but they, if you're a pine warbler, you like pine trees. And so there's no shortage of deer, there's a lot of hunting leases on this land. I can assure you there's every kind of mosquito and biting insect in those stands. Some studies that have looked at actually vegetation diversity that I'm a little more aware of. Even when we apply herbicides, virtually everything comes back. So we kill the red maples, but they reappear. So we're not really driving anything to extinction that I'm aware of. Others smarter than me in terms of biodiversity might argue otherwise.
At this point, if you have like native longleaf pine or something like that, which longleaf pine used to cover 90% of the southeast, it now covers something like 1%, and is the most diverse temperate ecosystem. If you have that now, there's other mechanisms to get credit for it. So pine plantations are not taking land that was pristine and turning it into pine plantations. It's the land that, the alternative might be development or might be farming. So, and they found I think in general that the diversity is not bad, and then it does provide corridors and some habitat in general, so in just open space. So.
If I could argue again, like right now what we're seeing in very South Georgia, North Florida, Louisiana, Mississippi, is frost-tolerant eucalyptus. If I had my preference, I would rather maintain monocultures of loblolly pine than monocultures of eucalyptus. So it's a gradient, they are definitely managed systems. They have some ecological benefits. They are native. North America in general benefits from that. We're not planting a lot of exotic species at all like the rest of the world for our forestry.
Yeah, they're actually planting
So
it in Argentina, in plantations in South America.
Oh yeah, right.
So they're taking our loblolly and planting it elsewhere.
That's true.
All right, well, I think I probably should let everybody go. It's
Okay.
it's 4:45.
If you'd like to ask your question
Right,
after
you're
everyone
welcome
leaves,
to
please feel
stay.
free.
That's all right.
Okay, I'll do
Let's take a speaker.